Okay, so in this video, let's continue our discussion on the asynchronous communication services. So in this, we'll discuss the next service that can be used for asynchronous communication, that is Apache Kafka. So with Apache Kafka, we can say that queues helps us to move the tasks, but Kafka captures the business history. So what do we mean by this? So Apache Kafka is basically an event streaming platform that stores the business events as a deliverable and replayable log, so that the multiple systems can consume the data. So with the multiple systems, I mean multiple consumer groups can consume the data. But when we discuss about the SQS or RabbitMQ, so basically SQS is nothing but a queue where the messages are stored and then get consumed by one single consumer. Okay, so that's an order in which the messages are consumed by one single consumer. But that's not the case with the Kafka. In the Kafka, multiple consumers can consume the same messages at the same time. Okay, but when coming to the RabbitMQ, so it's a message broker, and that will help us to route the messages to the between the services in real time, low latency, and with a point-to-point communication. So that we already discussed with the logistic services example. Okay, so now coming back to here, why we call Apache Kafka as an event streaming platform, because if we take the literal meaning of an event. So let's say take an example of cricketing event. So when there is a cricketing event, there is a series of things happens, right? First, there will be a pre-match presentation, then there will be a toss, then the batting side will bat, then the bowling side will bowl, then the post-match presentation, right? So all these stream of events gets completed. So that's how the that's why we call Apache Kafka also event streaming platform, because it helps us to capture the different events. For example, if we take the e-commerce application, then we'll have, when an order is placed, then there will be events of things that gets triggered in the system, right? So all the events need to be durable and need to be replayable and should be able to be consumed by multiple consumers at the same time. So all these features is provided by the Apache Kafka. Okay, so let's understand the working of the Apache Kafka here. And in this video, I'll not be showing you the demo and not going into much details about the Kafka broker and all these things, because I have created a separate full-length video on Apache Kafka and also showed you the demo and its related things like schema registry and all. So you can just check out that video in the other section. Okay, so I'll also provide the link in the description. So here, let's understand a simple flow how the Kafka works, and then we'll discuss what are the major advantages and why it is widely used in the industry. So again, here with the Apache Kafka, we'll have producers and consumers, and in between that, we'll have the broker. And in the broker, we create the topics. So it's a topic like as we created it in the SQS and also in the Redis, right? So similarly, here also we create a topic, and in the topic, again here, we'll have something called as partitions. Okay, so within one topic, we can have multiple partitions, and in those partitions, the messages will be stored. Okay, so when the producer produces a message, that message will get stored in the partition of the topic, and from those partitions, the consumer consumes that. Okay, so now from the consumer side, let's say if we have two consumers, okay, and in that case, every consumer will be assigned to one partition, okay, and from those partition only it will be get consumed. If we have more consumers in one group than the partitions, then the extra consumers will sit idle, because Kafka makes sure that one consumer can able to consume messages from only one partition, and this is how it is able to manage the high throughput. Okay, so and if we want the ordering of the messages, then whatever the key value we will send in the message, the key should be same for every message. So all these minute details I'll be discussing in the another video, but here just for your information and overview. So the message will be sent by the producer, it will be stored in the topics partition, and from that partition the messages will be then consumed by the particular consumer. Okay, and now it is a role of the group here. So let's say there is an order message. Okay, so this order message needs to be consumed by two different systems. One is order processing system and another one is analytical system. Okay, so there is one message and the requirement is two. So if we keep both the consumers in one group, then the message cannot be consumed by both the systems, because the offset will get changed. Okay, so once a consumer is consumes the messages from one group, then that message will not be again available for that group. That's the reason we create two different groups, and they will be subscribed to that topic. And in that case, the offset will be separately monitored or separately changed for different groups. So that's the reason if the same message is consumed by orders group, then the same message will be still available for consuming the other group like analytics. So that's not possible in case of the SQS, because in SQS every queue will be assigned to one single consumer, but here with one topic multiple consumer groups can consume the same message. Okay, so that's a simple overview of how the Apache Kafka works or is configured. Okay, so next let's discuss what are the major or the core features of the Apache Kafka that makes it stand out compared to the other asynchronous communication services, okay, and why it is widely used in the industry. Okay, so let's discuss what are some of the non-negotiables regarding the Apache Kafka. So the first one is, as we all know, it decouples the system. Okay, so here Apache Kafka makes sure that the services are loosely coupled, right? So we can have different services or the consumer groups that can independently consume the messages, as we discussed just before. So that basically decouples the whole system. So next day, if we want any other service to get to be added, like let's say notification service also wants to consume the order message, so we can just simply add it separately, and that will not disturb the existing services, right? So this is how the Apache Kafka helps in decoupling the systems, right? So that's the first major advantage of the Kafka. Next we have, that is the scalability. So that's another very major advantage, and that's why it is so popularly used in the industry, that is scalability. So with the scalability, how does it achieve the scalability? That is because of the creation of the partitions within the topic, right? So when we have multiple partitions within one topic, then the messages that are incoming to into the broker, that are distributed among the partitions, right? So if we have only one partition, and let's say if we have 100 messages, then all the 100 messages will get stored in that one partition, and then it will be available to be consumed by only one consumer at one time. But now when we divide that one topic into 10 partitions, then all the 100 messages will get divided into each partition. So now every partition will have 10 messages. So now with that, the consumption gets increased at per time, right? So the throughput automatically gets increased, and that is because it helps. That is because we are able to add the partitions, and messages get stored over there, and that can be consumed by multiple consumers, right? So that's the second major advantage of using the Kafka here. So that's the scalability. Next advantage here we have is the zero data loss. So that is because here data is first of all stored on the disk. That's the first reason. And second most important reason is we have in a broker cluster. Right now I have just shown you one broker, but in the production systems or in the major enterprise applications, we have multiple brokers in the cluster. So when we have multiple brokers, these topics gets replicated over there. So for example, if a message is saved in topic 1 in the partition 1, then the same will get replicated in the other brokers as well, and over there also it gets stored on the disk. So in this case, if let's say any day if any one of the broker goes down, then the message is still available in the other brokers. So because of this, we can say that it will helps us in the zero data loss. So if any one broker goes down, then we still have the message in the other brokers, and those messages are also stored up to 7 to 14 days. That can be also configured accordingly. Okay, so that's the another major feature, that is zero data loss in the Apache Kafka. So if we take a simple examples, so for the decoupling the system, for this I just added the example of notification system. So you can add a new system and that will not disturb the existing system, right? So if you take example for scalability, let's say we have created a ticket booking system for IPL. Okay, so here when the ticket booking starts, there will be millions of users trying to book the tickets, right? So here if we use Kafka, then a million users can click on buy at the same time, but the Kafka will absorb all those messages and it will be stored in the partitions, and then consumers will consume that in its own pace, and then the ticket booking process will continue. So with this, the database will not get overloaded, API timeout will not be there, and also the customer satisfaction will be there. So at the end, we can provide a best user experience when we have such a resilient system. Okay, so the next major advantage here we have is the replaying the messages. So with this, what do you understand? Let's take a simple example. Let's say there is a new code push into the production for one of the consumer service, let's say order service. So just a day back, a new code was pushed, but that code had some bug, okay? And the team got to know about that bug only when customers had a complaint the next day, okay? So let's say there was some time got elapsed, let's say around 2 to 3 hours when the code was pushed and when the team got to know about the bug. Okay, so now in this case, between those 3 hours, whatever the messages got consumed, that would have been processed, and that would have been saved in the database, and that would have been also sent to the other downstream systems, right? So now what we want here is immediately first of all, the code will be rectified, that is, it will be corrected and it will be pushed back. So once the new code will be pushed, that is, the fixed is done. Now what we ideally need, we want to consume back all those messages between those 2 to 3 hours, and then reprocess that so that the customers will get the right data, and also the database will have the correct data, right? So now this can be easily done with the help of Kafka. So for those 3 hours, what we can do, we can just reset the offset to the previous time. Okay, so we have that feature in the Kafka where we can reset the offset. So with offset, what I mean is, let's say offset is like an index, okay, within the partition in the topic. So right now, let's say if the index is at this point, okay, so let's say the index is at this point. Once the message is consumed, the index will move to the next point, and the message is consumed, the index will move to the next point. Okay, so like this, once the index or the offset is moved, that it is considered that message has been consumed. So now what we can do, we can just reset that offset to the 2 hours back, and we can make sure that consumer will again consume those messages, and again the database will get fed with the new data. But here what we need to make sure from the code point of view is that our consumers should be idempotent, okay, because if we reprocess the same message, then the database might get with duplicate values, and also the customers will get, or the downstream systems will get the duplicate messages, right? So for that, every downstream system and the database side, we need to make sure it is idempotent. So that's another major advantage which we hardly see in any of the other systems we have discussed till now, like RabbitMQ or SNS or SQS, right? So that's a major discussion I just wanted to do regarding the Apache Kafka. But if you want to understand deeply like how it is implemented and what are the other things that revolves around Kafka, you can just watch the video that I'll provide in the description, or you can just find on my channel. Okay, so that's about all the major asynchronous communication services that we had to discuss here. Okay, so next let's move on to the next section.